So we're going to walk through the review for the quiz on intervals for means. All right. So in this case, Ms. Prada, the production manager at the soda company, is doing the 1 in 6 game and is worried that the soda bottles are not filled enough. The target volume is 32 ounces. As the company statistician, you randomly sample 10 bottles with the following results. And it should say construct and interpret a 95% confidence interval for the mean volume of the soda bottles. So let's start with that. So just on the left, you just see the directions on how we do this. All right. So to construct, first we have the state, and that is, what are we looking for? We want to estimate the true population mean. So now some of you are like, well, shouldn't we have the word all? Whoops, that's not what I meant. I want a highlighter. All right, ignore that. So we have true and I have population. Remember the important part, I'll say mean volume of soda bottles. The important part here is we want to know that you're not trying to guess the sample, that you're trying to guess the actual population value. I know the sample. Well, I'm going to calculate it here in a little bit, but I see every data point up here. So it's not necessary for me to guess at the sample. I have it. All right. What method are we going to use? We're going to use a one sample t interval for mu, or the mean. All right. And I should define mu as that true population mean volume of soda bottles. All right. You took a we said you took a random sample from the production line. So we're fine. Okay. You randomly sampled 10 bottles. There it is. Let me go ahead and get my highlighter. So don't say assume if it says you did it. Randomly sample 10 bottles. So we did. 10% condition. I would hope that 10 bottles is less than 10% of all the bottles produced on the production line, even for that hour or day. Normality. So because this is such a tiny sample, you really should have a dot plot here. All right. And so this is just a quick graph of the dots. And all we're looking for is outliers or strong skew. All right. There is no extreme skew or outliers, so we're going to say our normality condition is met. We're not going to say our distribution is normal, but we're going to say we can approximate. It's probably approximately normal because nothing really scary here. Okay, so the first part is, now we're going to do the do. So we need to do some calculations. We're going to need the mean. So let's go ahead and show you how to use the calculator. So if you're needing the standard deviation or the mean of your sample, let's go ahead and review how to enter that and run one var stat. So you're going to hit the stat button. You see that in red. You just want to edit, so we can hit enter, or you could hit 1. And then we just type in the data. So I've got 32, 31.4, 31.6, 31.5, 31.4, 2.2, 31.8, 31.7, 32.1, and 31.6. All right. So it shows that I have 10 data points entered, and that looks good. Hopefully they are all correct, the values. And what I'll do is I'll go stat, calc, one var stats. And just keep list one. Frequency list, because it's just one list of data. It's not like repeated data points. We just leave that alone, and we hit calculate. And there is my mean and my standard deviation, which is right there, 0.2869, or if you round it, 0.2870. So now we have, we can fill it in. We have our degrees of freedom. Since it's one sample, this is easy to calculate. It's your sample size minus 1, so it's 9. There's our X bar from one var stats. Here's my standard error, or standard deviation of the sample, and I can calculate my standard error for my sampling distribution. So I take 0.2874 divided by square root of 10, and there it is. So, and if I want to find the calculate the critical value, it's inverse t, left area is 0.975. Remember, degrees of freedom is 9, is 2.262. So I'm going to skip doing the calculator on that, because most of the time when you're doing a confidence interval, honestly, you're just going to go ahead and use the calculator. Now, there are a couple ways to run the interval since we've already run one of our stats. So if we hadn't run one of our stats, so let's go to test, and you can go to, we're going to a t interval. It's just one sample. You'll notice it has one prop, but everywhere else it leaves off the 1, and it only shows, well, on props it likes 1. I don't know why, but everybody else is pretty much there are no 1s. So typically you're not looking for a 1. We're doing mean, so this is the t distribution. We're doing a confidence interval, so we're doing the t interval. All right, so if you have data, you can actually, and I think we need a 95% confidence interval, so that's fine. You can actually just hit calculate here, right? And it will, boom, there you go. The other thing you can do is since we already calculated the mean and standard deviation, is you can also run the interval that way. So if I go to stats, enter, and you can see it still remembers my mean and my standard deviation, and I can come down here and hit calculate. Both of those give you the interval. So there it is. So now that we have the interval here, basically there's the by hand calculation, but here it is from the calculator, and it gives you the degrees of freedom. Lastly, we add the conclusion. It's always we are blank % confident. In this case, we are 95% confident that the interval from 31.533 to 31.939 ounces captures the true population mean volume of sodas produced on the production line. By the way, if our numbers vary very slightly, it's not the end of the world, because if you have a by hand calculation, which I'm pretty sure that's where I got this from, or if you do a calculator version, they're going to vary slightly. So as long as you're pretty close to this, don't worry too much. So now on to the next part. A mechanic comes and adjusts the machine. You take a new sample, 36 bottles, and the new average is 32.1, with the standard deviation of the sample being 0.5 ounces. Now I went ahead and left this value up here because we're going to need that. So calculate and interpret a 99% confidence interval for the difference of before minus after. Assume all conditions are met, and you may skip the state and plan steps. So, hey, read. If you don't have to do these conditions, don't do the conditions. Now, if you do them correctly, you're fine. But if you don't, then that's a place for you to make a boo-boo and lose points that you didn't have to lose, all right? So let's go ahead and use the calculator. So now that we want to do an interval for the difference in means, we're going to hit stat, go back to test, and so we're doing an interval. So it's 2 samples. We're trying to do an interval, so we keep scrolling. 2 t int, that's what we want right there. Okay, so we're doing a t interval, but it's 2 samples. Last time we did 1 sample. And so now I can't put data in, because I could if I had list 1 and list 2. But in this example, I only have data for the first set. So I'm not going to need to enter the mean. So last time we had 31.736. My standard deviation was 2.287, and it was a sample of 10. X2, so my mean for the second sample is 32.1. Oh, yeah. And my standard deviation is 0.5, and it's a sample of 36. This time we're doing a 99% confidence interval, so adjust that. Never jump in the pool. Always say no there and hit calculate. And there's your interval. So you can see, there it is. There are your degrees of freedom. Now you're probably going, well, wait a second. Shouldn't I be using conservative degrees of freedom? We have the technology, so it makes sense to use it. If you use the calculator instead of calculating by hand, please report the degrees of freedom from the calculator. It should be consistent with your interval. And that's it. So now we have, using technology, there's our interval. And how do we interpret it? Well, I could say if the difference of before minus after is exactly this. You can also kind of say, oh, lower and higher. So be careful when using lower and higher, because you have to actually be accurate in the direction there. So I went ahead and used the more complex wording. So we are 99% confident that the true average fill volume before was between 0.7065 and 0.0215, lower than the true average fill volume after the mechanic adjusts the machine. Now, the reason that this is giving me a negative interval is we were before minus after. If I had asked you after minus before, this might be more comfortable and it would be a positive interval. Okay, so last but not least, we're going to go ahead and evaluate the hypothesis. So our hypothesis is before minus after is 0, the mechanic didn't do anything. And then our alternate, because we have this weird before minus after, the before should be lower than the after if he did his job. So this difference should be less than 0. Since this is all negative and 0 is not in the interval, we reject the null hypothesis that the machine is still filling at the same level. We have evidence that it's definitely down below 0 for the alternate. All right, so what significance level did we use? So when we do a hypothesis test, usually you're probably tempted to say, well, it's a 99% confidence interval, so the alpha is 1%. But pay attention to the alternate hypothesis. We're not testing for both ends. We're only testing for the left end. So I'm going to take that 100% minus the 99%, and I have to divide it by 2. So instead of 1%, it's 0.5%. All right. Or if you write it in decimal form, 0.005. Good luck on your quiz.